API response times just jumped from 50 milliseconds to 8 seconds. The culprit? A single chef search query that brought down your entire fleet. Let's break down Ansible versus Chef versus Puppet versus SaltStack, how it works, and the exact mistake behind that failure. Configuration management tools let you define your infrastructure as code. Instead of SSHing into each server manually, you write a playbook or recipe that describes the desired state, and the tool makes it happen. The fundamental architectural split is push vs pull and agent versus agentless. Ansible is agentless push. It SSHs into nodes. Chef and Puppet are pull-based with agents. SaltStack is hybrid using 0MQ. This single decision determines your latency and failure modes. Here are the basic commands for each tool. Ansible pings via SSH, Chef runs a recipe locally, SaltStack sends a command over 0MQ, and Puppet connects to its master. The language barrier is the #1 reason teams abandon a config tool. Ansible uses YAML, which is easy to read but limited. Chef uses full Ruby, which gives power but can become spaghetti. Puppet has its own DSL, and SaltStack balances YAML with Python for custom modules. All 4 examples install Nginx and Git. Notice the syntax differences. Ansible is pure YAML, Chef uses Ruby blocks, SaltStack uses YAML with a state name, and Puppet uses its own DSL. Ansible's SSH-based push doesn't scale linearly. Each node requires a new SSH connection. On a 1,000 node run, the control node's CPU and file descriptors become the bottleneck. SaltStack uses persistent 0MQ connections, making ad hoc commands near instant. Ansible takes 45 seconds to ping 1,000 nodes, while SaltStack does it in under a second. Chef distributes load across nodes, so server CPU stays low. All 4 tools claim idempotency, but they achieve it differently. Ansible checks each resource every run, which is simpler but slower. Chef and Puppet maintain a local state file and skip unchanged resources, making repeated runs faster. Chef and Puppet skip installation if already installed, making subsequent runs faster. Ansible always checks, which is simpler but slower. The ecosystem matters because you don't want to reinvent the wheel. Ansible Galaxy has the most roles, but many are shallow. Chef's cookbooks tend to be more thorough. Don't choose based on ecosystem size alone, you'll write custom modules anyway. Each command downloads the module to your local file system. Always pin to a specific version in production to avoid breaking changes. Config management tools are overkill for small setups. If you have 5 servers, use shell scripts. For containers, use Kubernetes. For secrets, use a dedicated tool like HashiCorp Vault. For ephemeral nodes, bake the config into the AMI. Using Ansible to deploy a single Docker container is like using a sledgehammer to crack a nut. Docker Compose is simpler. For 3 identical servers, a bash script with cron is enough. This is the same issue we highlighted at the start. Here's exactly why that happened. A new cookbook used Chef's partial search across all 500 nodes to find database hosts. The search query was unindexed and scanned the entire node object, causing a 30-second timeout per run. The Chef server's PostgreSQL was overwhelmed by concurrent searches. The root cause was an unindexed Chef search across 500 nodes, which caused PostgreSQL timeouts. The search query scanned all nodes without an index, overwhelming the database. The fix was to replace Chef search with a data bag lookup, which is indexed. We also added a search timeout of 5 seconds and cached results locally. This reduced search frequency from every Chef run to once per hour, eliminating the bottleneck. Never use Chef search in production without indexing and timeouts. It's a distributed query that scales poorly beyond 100 nodes. Use data bags instead. If your team doesn't know Ruby, Chef's Ruby DSL becomes a barrier. For simple package installation, Ansible's YAML is much easier to read and maintain. Default forks equals 5 means only 5 concurrent SSH connections. For 5,000 nodes, that's 1,000 sequential batches. Always set forks to at least 50, and consider using Ansible pull for large fleets. Never install the latest version from Galaxy or Supermarket in production. Pin to a specific version in your requirements file to avoid unexpected breakage. The article uses Ansible Galaxy install Jirlingai, Nginx, which is the legacy role format. As of Ansible 2.1, roles are distributed via collections. Use Ansible Galaxy Collection install Jirlingai, Nginx instead, and reference roles with fully qualified collection names, e.g., Jirlingai, Nginx, Nginx. The article mentions Ansible pull in passing, but doesn't show it. For large fleets where push via SSH is too slow, Ansible pull inverts the model. Each node pulls its playbook from a Git repo and runs locally, reducing control node load. The article warns about Chef search performance, but doesn't explain indexing. To avoid search timeouts, create a search index attribute in your cookbook and use knife search with indexed fields. Alternatively, use partial search with a limited set of attributes to reduce data transfer. Here's how to diagnose common issues. For Ansible SSH failures, use VVV for verbose output. For Chef search timeouts, increase the timeout in client. RB. For Puppet certificate errors, sync time and regenerate certs. For Salt Stack, check minion service and firewall. Let's run through some common interview questions. How does Chef's node object differ from Ansible's fact gathering? Chef's node is persistent state. Ansible's facts are fresh each run. When choose Salt Stack over Ansible for 2,000 nodes. Sub-second ad hoc commands and event-driven orchestration. What happens when Puppet agent fails to reach master? Uses cached catalog if available, otherwise fails. And a few frequently asked questions. Which tool is easiest to learn? Ansible due to YAML and agentless setup. Which is best for compliance? Puppet has built-in drift detection. Chef Inspec is best in class. Which is fastest at scale? Salt Stack, thanks to 0MQ message bus. Let's recap the key takeaways. Ansible dominates new deployments, 42% share. Ansible is easiest to learn, YAML, agentless. Puppet excels at compliance, Salt at scale. Agent-based tools have ongoing maintenance costs. Ready to go deeper? Up next, Ansible best practices and project structure, then Ansible ad hoc commands guide, then your first Ansible playbook, and Ansible installation guide. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.